Alright, welcome to part 4 of Statics Exam Review 1. We're going to be going over chapter 3 in this part of the series. We're going to be looking at problems 3.3. So to start off, go ahead and feel free to pause the video, turn to your book, find this problem, read it out, get your given, find, and your free biodiagram set up, and then we'll get on to it. I'm going to go ahead and read it out just so we can hear it. The problem states, it is known that a vertical force of 200 pounds is required to remove the nail at point C from the board. As the nail first starts moving, determine A, the moment about B of the force exerted on the nail, B, the magnitude of the force P that creates the same moment about B if alpha is 10 degrees, and part C, find the smallest force P that creates the same moment about B. That being said, feel free to go ahead and pause and catch up. We're going to go ahead and start on it. Start off at part A. We're going to find the moment about B. To find the moment about B, we're going to take our R, which is going to be CB, cross our FN. FN being our 200-pound force needing to remove the nail. And since we have been given all of the data, we can just simply plug it right on in. So our distance between B and C is 4 inches. Crossed our force, which is 200 pounds. Therefore, our moment about B will equal 800 pound inches. Do you note this notation? That is how you state a moment. If you leave off your inches, you will lose points. Alright, pretty quick and easy. Part B is next. So to find part B, which is going to be find the force P, we can just look at the moment again. So we're going to take the moment about B is equal to RA cross B this time, times our force P that's causing the moment about P, sine theta. Now to find this theta, all we need to do is look up, we've been given a 70-degree angle from the left of AB. So all we do is take 70 degrees, subtract 180 degrees from it, you're going to get 110. Add your alpha, because they gave us alpha as 10 degrees, we're going to get 120 degrees from this part of the horizontal will be our angle. Again, this is not drawn to scale, so it might look like it's larger, but mathematically this is how it's going to come out. That being said, we have our theta as 120 degrees. We're going to have 18 inches this time times P sine of 120 degrees. We solved for our moment earlier, which is going to be 800 pound inches. Kind of hard to write in there. We find force P, solving for P, we find force P to equal 51.3 pounds. Moving on to part C, we need to find P min, which is the minimum force P needed to exert to remove the nail. To find this, you can just start off again at the moment about B, which will be our distance time P min, distance being our RA B. We have 800 pound inches is equal to 18 inches times P min. Solving for P min, we get 44.4 pounds. It's a really good problem from chapter 3, knowing how to use it. Finding angles, that's not been given. Do pay good attention to this one. Very similar problems going to be like this on the exam, as well as the same thing will go for problem in the next continuing part of this chapter.